Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hi students, welcome to Brilliant Katha. Today we're going to be discussing on matrices and determinants, the first and the most important topic in MCQs in mathematics board exam. You can see from the sample paper around 4 or 5 questions comes from this unit. So it's a lot of important for this unit. So many properties are coming. So stay with me. You will be getting almost all the properties you need to study in these 2 chapters. Okay, let's go into the questions immediately, my dear students. Question number 1. If for a square matrix A, which follows the matrix equation A squared minus 3A plus I, A squared minus 3A plus I equal to 0. And you have to get the inverse of this expression. How to get the inverse of this expression? You simply multiply A inverse throughout. So A inverse A squared minus 3 A inverse A plus I A inverse is equal to 0 A inverse. It's a very important question. Getting the inverse of a matrix from the matrix equation, my dears. So multiply A inverse A squared A inverse A, I A inverse, 0, A inverse, 0. So my A inverse expression is, it's going to be 3I minus A. I'm just comparing it with what they have given me. They have given me XA plus YI. So I can say that X is equal to -1, Y is equal to 3. So what is X plus Y? It's going to be option B, 2. Yes, option B, 2. Right answer coming up. Yes, Mohammad Hisham, Ruben, just check your answers. 2. Yes, all of you. It's a very, very important question. Just making the inverse of a matrix from the matrix equation. Okay, and direct question often comes, what is the inverse equation or from the matrix equation? Just multiply inverse throughout, my dears. Next question, A is given to me, and this is going to be a very important concept of multiplying equations. See, normally you see this as A plus B into A minus B, which in algebra is A squared minus B squared. Please, my dear students, algebraic formulas should not be used in matrix multiplication. Please, you do just bracket multiplication, my dears. 3I plus 4A multiplied with 3I minus 4A equals X squared I. Simple to bracket multiplication, it's going to be 9I squared minus 12IA plus 12IA minus 16A squared equals X squared I. See, if you use matrix algebra here, just multiply the bracket terms, my dears. Do not use algebra. In this case, we have seen that these two are same. because multiplying an identity matrix, my dears, multiplying an identity matrix doesn't make a difference. So AI equals IA always. But in normal multiplication, if A into B is defined, but it need not be equal to B into A. AB need not be equal to B into A. So please do not use algebraic formulas of A plus B whole squared, A minus B whole squared, A squared minus B squared, but simply open using bracket multiplication. In this case, AI equal to IA, that's why I can cancel. Now my dears, what's 9I squared? I raised to any natural number is still the identity matrix. Then 16A squared. Now this is A. What's A squared for us? A squared is simply multiplying the matrix A with itself. You try multiplying it, you will definitely see that you are getting 0, 0, 0, 0, 1, minus 1, 0, right? So, sorry. The first one is not 0. The first one is minus 1. Minus 1, 0, 0, minus 1. So it's minus I. So your A squared is minus I. So it's going to be 9I plus 16I, which is 25I. Okay, so 25I is what you're getting. So x squared I equal to 25I. So x squared equal to 25. X is equal to plus or minus 5. Option C, yes, right answer coming from Knight, Ayan, Satvik, yes. Others also, please try giving answers. Please make sure, once again I'm telling you, do not use algebra formulas in multiplying. Do not use algebra formula in multiplying. Students, please come back to you in the chat box and start giving answers, my dears. All of you start giving answers in the chat box, okay? Next one, A is given, B is given, they say A equals B squared. A equals B squared. So A equals B squared, I can say 1, 0, 2, 1 equals B squared x 0, 1, 1 multiplied with x 0, 1, 1. So it's 1, 0, 2, 1 equals, get the product, x squared 0, x plus 1, 1. On comparison, please compare the two matrices. When you compare the two matrices, you get x squared equal to 1 in one case and x plus 1 equal to 2 in case 2. X squared equal to 1 means x is plus or minus 1. X plus 1 is equal to 2 means x equal to 1. Now, do we have a unique value for both these cases? If we have a unique value, then that is the answer. 1, positive 1 is a unique value in both the cases, okay? Case 1, case 2 has a unique value called 1. But I will reject minus 1 because it doesn't satisfy case 2. Now what if both the cases does not have a unique value? Like for example, I got the first case as 2, the second case as 3. Then what will your answer be? You will have an option which says no real values. Do not tick one of the options saying, oh, it is satisfying one case. You have to check all the cases of x. If one value of x satisfies throughout all the cases, that is your answer. If there is no single value which satisfies all the cases, you say there are no real values for x. So please make sure you're careful about this, my dears. Yes, right answer coming from Hisham. Yes, Knight, Satvik, Sai. Good answers. Okay. Others also please try to give answers. All of you become active. Do the calculations and get the answers quick. Okay, so now next one. They're saying that a plus a dash is equal to root 3i. It's a common question nowadays to bring trigonometry inside matrices. So what happens with a plus a dash? You know that a dash represents what? Transpose. A dash represents transpose. So add A and A dash. So cos x, then sin x, then negative sin x and cos x is added with its transpose. Cos x transpose means rows become column and columns become row. Interchange rows and columns. Yes. So what happens if you add 2 cos x first element, 0, 0, 2 cos x is the last element, and that's equal to root 3 1001. So definitely you can see that you get two cases, but both the cases are same. Both the cases are same. So I get 2 cos x is equal to root 3. So cos x equals root 3 by 2. Come on, my dears. Options. Yes. Answers coming up. Good. Very good. All of you. Right answers. Cos pi by 6. Cos pi by 6 is root 3 by 2. So your answer is option B. Yes. There is only one angle given in the options which satisfies it. So that, because they're all talking about acute angles between 0 and 90, so you just think about that. No need to think about the fourth quadrant where again you get a root 3 by 2. Yes. So that option is not there, so you can reject it. Fine. Next. Again, it's a very common pattern to ask this. Yes. That's like, this is last year's question. Board exam question. They wanted to find A raised to 2023. A very high power. Do not be worried about the power, my dears. You just try to identify the pattern that the matrix follows when the power increases. So what's going to be A squared? 0, 1, 0, 0 multiplied with 0, 1, 0, 0. So you see that the first term is again 0. The second term is again 0. The third term is again 0. The fourth term is also 0. You saw that A squared became 0. You can check. A squared is becoming 0. Once A squared became 0, then what would happen if you keep on multiplying A cube? It's A squared into A. And since A squared is 0, it again becomes 0. And whatever I do to the power now, what is going to happen? What is going to happen? It's going to always turn to 0. You keep on increasing the power, it becomes always 0. So I got the pattern that it's going to become 0. So my answer is what? Option C, 0. Right answers coming from, yes, Fahad, Hanna, Isham, Habib, Sainair, Hanna. Yes, very good, my dear students. Keep doing it. Keep doing it, my dears. Come on. Next question. A is a 2 by 3 matrix such that AB and AB dash both are defined. Very important, my dears. The product of two matrices. See, if I have to say that a matrix of order m by n and another matrix of order p by q can be multiplied, the only necessary condition is that n of the first matrix becomes equal to p of the second matrix. The necessary condition is that the n of the first matrix, that is the columns of the first matrix, must be equal to the rows of the second matrix. And what is going to be the resultant product? AB. AB will be a new matrix and the order of that matrix will be M of the first matrix and Q of the second matrix. So M and Q is just to tell the order of the product. And what will be the necessary condition that you must remember? That n is equal to p. Very important question about the product. Now the question here says that both AB and AB dash are defined. So A is a matrix of order 2 by 3. And I don't know what's the order of matrix B. So let me say it is P by Q. But according to the rule, if AB is defined, the product AB is defined, the necessary condition says that P value should be 3. Correct? AB is defined. So now what are they saying? Now A and its transpose B dash. What will be the order of B dash? B dash will reverse row and column, right? So P by Q became Q by P. Now what's the necessary condition for this to be defined that 3 will be equal to Q. So I got P as 3, Q also as 3. They want the order of matrix B. We assumed that matrix B has order P by Q. So it would be of order. Come on, answers coming up on the screen. Yes, Magashri, Fahad, Hanna, Simra. Yes, good all of you. It's a matrix of order 3 by 3, my dears. A matrix of order 3 by 3. Very, very important question for you to study. Okay. Product, and then hence say that the product is defined and they're asking you to find the order of the matrix. Order of the matrix. Okay. Good, good. Satvik, Manjanada, all coming with the right answers. Next one. Oh, this is already done. I'm sorry. Look at this matrix now. If A is a 3 by 4 matrix and B is a matrix such that A dash B and AB dash, this time they are saying A dash B and AB dash, both are defined. So they gave me a matrix A of order 3 by 4 and I am assuming another matrix B of order P by Q. Now they say that A dash B. So A dash will have matrix of order 4 by 3 and B will be saying that, what is P? What is P? 3. Now A and B dash. A and B dash, my dears. So what is going to be B dash? Sorry. B dash would be Q by P. Can you please compare and say that if that has to be defined, Q is equal to 4. If that has to be defined, Q is equal to 4. Then what will be the order of the P by Q matrix? The order of the P by Q matrix will be, right answers coming up. Yes, all of you. Isham, Fahad, Simra, Nachiapan, yes, Magashri, Satvik, very good. Very good answers coming up, all of you. The matrix will have order 3 by 4. Please learn this pattern. This is a very, very important question for you. Next, yes, coming. Another pattern. Symmetric, skew symmetric. Now, please tell me, how would a matrix become symmetric? First of all, it should be a square matrix. To discuss about symmetric and skew symmetric, the matrix should be a square matrix. Now please tell me, what is the condition for a matrix to become symmetric? If a matrix has to become symmetric, first of all, its transpose must be the matrix itself. Its transpose must be the matrix itself. To become skew symmetric, its transpose must be a negative of A. To become skew symmetric, a matrix transpose must become the negative of A. Now look at the question here. They say that A is symmetric. So if A has to become symmetric, Y minus 3 minus 1 3 will be equal to its own transpose 1 4 x z 2 y minus 3 minus 1 and 3. Please compare. When you compare, can you see that 4z x minus 3 and y minus 1? So what is x? Minus 3. What is y? Minus 1. And what is z? 4. So what is going to be the value of x plus y plus z? Minus 3 minus 1 minus 4 plus 4, answer 0. Yes, right answer coming, all of you. Very good. Yes, Fahad, Knight, Magashri, Sai, Satvik, Hanna, Hisham. Very good, my dears. All of you giving the right answers. Option D, x plus y plus z equal to 0. Simple logic. Two matrices has to become symmetric. Its transpose should be itself. So just compare the two matrices. You will definitely get the unknown variables x, y and z. Otherwise they wouldn't ask a question like this. Next, Another one. See, this is a very, very important property you must study. First of all, let me say the property itself. How can I express a matrix, any square matrix, as the sum of a symmetric and skew symmetric matrix? They said that this square matrix is equal to P plus Q. P is symmetric, Q is skew symmetric. Let me assume that this matrix is A. According to the property, any square matrix A can be represented as the sum of a symmetric and skew symmetric matrix, as P will always be A plus A transpose by 2 and Q will always be A minus A transpose by 2. Remember it, it's a very, very important condition that you have in the textbook. When a matrix, a square matrix, is to be represented as a sum of a symmetric and a skew symmetric matrix, this would definitely be a symmetric matrix, and this would definitely be a skew symmetric matrix, my dears. If you use that logic, they are asking you to find the skew symmetric matrix Q. They are asking you to find the skew symmetric matrix Q, my dears. So what will be your skew symmetric matrix? A minus A dash by 2. That is equal to, what is your A? 2, 0, 5, 4 subtracted with its transpose 2, 0, 5, 4, the whole divided by 2. So 2 minus 2, 0 by 2, 0. 0 minus 5 by 2, negative 5 by 2, positive 5 by 2 and 0. Exactly, this is a skew symmetric matrix. Yes. Options coming up already on the screen. Knight, Manjunada, Chris, Simra, yes, Magashri, Fahad, Muhammad Isham, Nachiappan, yes, all very good. It's option B. It's a very, very important property you must remember. Now, along with this question, I would like to introduce few more things with regard to these concepts. Okay, for any square matrix, remember it, for any square matrix A, okay, A plus A dash is symmetric. A plus A dash is symmetric. A minus A dash is skew symmetric. Okay, this expression that I gave you is to convert a symmetric plus a skew symmetric back to A. For that I have to divide with 2. I have to add and divide by 2, then only I'll get A. But this is a straightaway question where a sum of a matrix and its transpose always gives you a symmetric matrix. A minus A dash is skew symmetric. Okay, there are few more concepts. Just remember, A and B are symmetric. If I have two matrices A and B which are symmetric, please remember AB plus BA, AB plus BA, the reverse product BA added will always give you a symmetric matrix. It's better you by heart these things. These are all good questions for MCQ. AB plus BA, any matrix in the form, even sometimes they will put transpose on this expression. Even if there is a transpose on this expression, still the condition satisfies. Okay, keep in mind, AB minus BA is always skew symmetric. Please, my dears, by heart this, it's always useful. AB plus BA is symmetric. AB minus BA is skew symmetric. They will sometimes put transpose on top of it. Still no change, the property still holds. Okay, next one. Yes, another very important pattern. AB equal to A, BA equal to B, then which of the following is true? Now the problem is we don't know what to check here. But look at the options. In the options, in all the four options, they are trying to equate A squared and B squared. That's a hint we have. In all the options, they are trying to equate what? A squared and B squared. So please keep this logic in mind when you are facing this question. Okay, now let us try to find what A squared is. A squared is normally A into A, yes. But A, according to the question, is AB. Right? A according to the question is AB. So I can write A squared as A into A, that is equal to A into AB. Correct? If I use this, continue this like this. what is going to be b squared? B into b. Yes. So what is b squared? B into b. So can I say b into b, which b is equal to? Wait 1 minute. B into b, where b is equal to ba. Yes. Here also I have to make that change. The second a can be written as, the first a can be written as ab into a. Okay. This is what you need to do. The first a became ab. Here the first b became ba. Now read this part of the expression, my dears. What is ba? ba is equal to b. And what is this? ab is equal to a. Okay. Now what is ab again? ab is equal to a. What is ba again? b. So the logic is how I can connect it with the expression again and again and again. For that, first substitute the first a as ab. Then associative property says I can multiply it in any order. So ba will become b. But again back ab becomes a. Same logic, change the first b to ba. Then the second ab becomes a. b into a back to b. So I got a squared equals a. b squared equals b. Option A. It's actually confusing sometimes. That's why I said listen very carefully. First a, then the second product, then it comes back to the original one. Okay. Very simple logic. Try checking it, my dears. It's very simple to do it. Check it. Next, if a and b same pattern. Now this time they ask me what is a squared plus b squared. If I do the same logic, what would your answer be? Before you said a squared is a, b squared is b. And if you use that same logic, can you try to answer this question now? Yes, right answer coming from Hisham. Yes, anyone else? Magashri, right answer. Yes, my dears. If a squared is a and b squared is b, from the previous question we know that. Okay, so then we can say the answer is going to be option C, a plus b. Simple logic. You can use the same idea we used before and we can use this. Okay, that is very, very important to know how to apply it, my dears. Very, very important to know. Yes, Manjunada, Chris, Hanna, very good, my dears. Yes, very good. Keep it up. Okay. Yes, number of symmetric matrices of order 3 by 3. See, normally we learn questions where order is there, which is n by n, and the matrix allows only say like 3 entries, 4 entries or 5 entries, only whatever is said, only m entries. If this is your question, then your answer is going to be m raised to n by n, n into n. What is the answer? Number of entries raised to the product of the order, n into n. M raised to n into n. This is the answer for a question where they do not say symmetric, skew symmetric, any square matrix, any matrix of order n by n, which allows only m entries. Then the answer for number of matrices equals m raised to n into n. Last time in the board exam, they asked not any matrix, they asked a symmetric matrix. Okay, for symmetric matrices, number of symmetric matrices, my dears. So number of symmetric matrices, the answer was m raised to n into n plus 1 by 2. Number of entries raised to n into n plus 1 by 2. Then for number of skew symmetric matrices, number of skew symmetric matrices is equal to m raised to n into n minus 1 by 2. That is n into n plus 1 by 2. This is n into n minus 1 by 2. Here the question is of order 3 and only 2 entries are allowed. So here M is 2 and N is 3. A matrix of order 3 by 3 means N is 3. And number of entries only 1 and minus 1 is allowed, only 2 entries. Then tell me what is the number of symmetric matrices? Number of symmetric matrices is going to be 2 raised to 2 entries raised to 3 into 3 plus 1 by 2, which is 2 raised to 3 into 4 by 2, which is 2 raised to 6, which is equal to 64. How many symmetric matrices can I form? 64. Option B, right answer coming from Hanna, Magashri, Sai. Very good. So please learn these two formulas. Number of symmetric matrices, number of skew symmetric matrices. Okay. Next question. Yes. If n by n matrix is formed with 3 possible entries, so my M is equal to 3. I have 3 possible entries. Now, what would be the answer for the number of such skew symmetric matrices? 3 entries, and they did not give me what the order is. They gave it as n by n. So my answer is going to be n into n minus 1 by 2. Straightforward answer here. 3 raised to n into, yes, Magashri, Simra, very good, John. Right answers, all of you. So please, my dears, these two formulas are not there in the textbook. It's not there in the textbook, but they asked it. So are you all clear? Yes. Moving on. A and B are skew symmetric. That means A transpose is minus A, B transpose is minus B. They said of same order, because otherwise we cannot take the transpose and say the product is defined. There could be a confusion. If order is same and if it is skew symmetric, it must be a square matrix whose transpose will also have the same order. Okay, so AB is symmetric. So AB is given to be symmetric, then what is the condition it will satisfy? So AB is symmetric means AB transpose will be equal to AB. According to properties of transpose of matrices, what will be AB transpose? I will say it is B transpose into A transpose. AB transpose, another one is a very similar property like this, AB inverse. It's B inverse, A inverse. So we have two properties which looks very similar. So AB transpose, apply it, B transpose, A transpose, AB. Now B transpose is minus of B. A transpose is minus of A. And minus B minus A is BA equals AB. BA equals AB. Option C. That's the answer. See, these kind of simple property based questions and product of two matrices are very important for us. Please focus on these kind of questions for the MCQs of matrices. Okay? Yeah. Now we are moving into questions based on determinants, my dears. Matrices, I've covered some important questions. Now moving on to determinants, and if we have time we will go to more questions. Okay? If A is a skew symmetric matrix of order 3, then determinant of A is equal to X. Very powerful property coming here. Many of you do not remember also this property. For any skew symmetric matrix, of odd order, odd means 1, 3, 5, 7, the order is going to be odd order, then determinant value will always be 0. No need to calculate. No need to calculate, my dears. For any skew symmetric matrix with odd order, the determinant value will be 0. They gave me a skew symmetric matrix of order 3 which is definitely odd. Yes, then we can say that determinant of A equal to X equal to 0. Now they're asking me what is 2023. This is last year's question. That's why 2023. 2023 raised to X. 2023 raised to 0. 1. Option D. Now, how many of you can tell me which all matrices will always have a determinant equal to 0. I could say a singular matrix. If A is a singular matrix, if it is stated in the question that A is singular, immediately conclude that this matrix has determinant equal to 0. Another one is already said, skew symmetric matrix of odd order. Skew symmetric matrix of odd order. Another one, if any two rows or two columns of a matrix are equal, same elements, same corresponding elements in rows and columns, any two rows, any two columns, then determinant equal to 0. These are few important things you must remember for making the determinant 0. I gave you now 3 cases. Yes, 3 cases where the determinant of a matrix can be 0. Yes, right answer, all of you, option D, 1. Option D, 1. Yes, right answer coming from Hanna, Simra, Sai, Nachipan, Satvik, Magasri. Yes, very good, my dears. A and B are square matrices of same order. Then what is A plus B whole square? So normally when you see A plus B whole square, you will immediately think about the algebra formula A squared plus 2AB plus B squared. Wrong. In matrices you cannot do that. I told that in the first question itself. In matrices you cannot do like that. We must consider it as normal bracket multiplication. And if you open the bracket, it becomes A squared plus A into B plus B into A plus B squared. In normal mathematics, AB equals BA, but in matrix multiplication, AB is not equal to BA all the time. Can anyone tell me what is the only condition where AB will be equal to BA? AB equal to BA, the only condition, can anyone tell me in the chat box, when does AB become equal to BA? The only case where AB becomes equal to BA. No, I'm not asking about the answer. I'm not asking about the answer. The only case when AB becomes equal to BA. I think you are getting confused. You're trying to give me the answers. AB becomes equal to BA if and only if B is the inverse of A. B is the inverse of A. That is, if any two matrices where B is the inverse of A would be A into A inverse equal to I. This is the only case where you can consider AB equal to BA. But now here they are saying that this is equal to A squared plus B squared. They are saying that this expression is equal to A squared plus B squared. Then this happens if and only if AB equal to BA. Correct? If and only if what? AB equal to BA. This can, no, AB equal to, sorry, AB equal to minus BA. AB equal to minus BA. AB equal to minus BA. Option B. AB equal to minus BA. Then the only case, okay. So I can write as minus BA plus BA will cancel off. The only case where this is going to happen. Correct? So I have to remember this necessary condition. Along with this, why I am saying that you cannot always expand A plus B the whole square in matrices using algebra formula. You have to use bracket multiplication. Remember it. It's A squared plus AB plus BA plus B squared. And these two will be equal only if B is the inverse of A. Got it? Okay. And if this has to disappear, AB must be equal to minus BA. Option B, right answer coming from Sai, Night, Chris. Yes, Satvik, Coffee, Snow. Yes, your names are not there, so I just have to say your ID. That's it. Okay. Now next one. A is a square matrix and A squared equal to A. Then I plus A squared minus 3A is equal to A squared equal to A. I plus A squared minus 3A. So I plus A squared is like what? I plus A into I plus A minus 3A. So it's going to be I squared plus IA plus AI plus A squared minus 3A. Okay. So I squared is I itself. Yes. IA, AI multiplying with identity matrix, the value doesn't change. A plus A, and A squared is again given as A minus 3A. So I plus 3A minus 3A. Cancel. Easy question. I. A normal bracket opening question. Again, I'm telling you, do not confuse yourself. In this case, though IA equals AI, I did not use algebra formula. My concept is very clear. In all these questions, you must always use bracket multiplication. Please remember. Yes, right answer is coming. Yes. Night, Hanna, Simra. Yes. Sai. Very good. Next, A is a non-singular matrix. Just now I said about a singular matrix. What is a non-singular matrix? Singular means, what is a singular matrix? The determinant is equal to 0. Then definitely what is meant by non-singular? All of you, non-singular means the determinant of A should not be 0. Then what is the value of A so that it must remain non-singular? So that is the determinant 1, 2, 1, 2, 3, 1, 3A1 should not be 0. So open the determinant 1 into 3 minus A minus 2 into 2 minus 3, okay, plus 1 into 2A minus 9 not equal to 0. Simplifying it, 3 minus A plus 2 plus 2A minus 9 not equal to 0. So you get A not equal to 4. A is not equal to 4, my dears. So the only situation where this is going to remain non-singular is when the value of A is not 4. What is the meaning that the value of A is not 4? It simply means that it can be any real number except 4. They said it's not 4. Then what is it? It is anything other than 4. So it's going to be option D, R minus 4. Very good, very good. Yes. More number of answers coming now every time now. Okay. So my dears, others also please, all of you who said the answer right now is correct. So others also please make sure you are trying to solve it like this. So if you're able to do it this fast, you will be in very good speed for MCQs in the exam. Okay, under 30 minutes we should be able to answer all the MCQs including the assertion reason. Under 30 minutes, then you will be in good pace during the exam. Okay, next one. Yes, another property based question in determinants. Determinants has a lot of properties to study. Okay, this is another one. So remember, I'm telling the property right now. Property that is being highlighted here. There are two properties being highlighted here. One is, what is the determinant of A inverse? It's 1 by determinant of A. What is the determinant of A inverse? 1 by determinant of A. The next property, what is the determinant of a scalar multiplied with a matrix? It would be k raised to n into determinant of A, where n refers to order. Order of the matrix is n by n. Two properties which is going to be used in the same question. One is, what is determinant of A inverse? Second one, what is determinant of Ka? K raised to n determinant of A. So here, can you see that the first left hand side is A inverse divided by 2. According to the property number 2, this 1 by 2 can come out with raised to n and it would remain as determinant of A inverse. Here it's a 3 by 3 matrix, so my n is 3. So 1 by 2 cubed into 1 by determinant of A. Okay, that is equal to 1 by 8 into 1 by determinant of A. Now compare it with the right hand side, my dears. What is my right hand side? My right hand side says 1 by k into determinant of A. So can I compare and say k is equal to, simple answer, 8. So what is my option? Option B. Some of you might confuse and say 1 by 8 because you see 8 in the denominator. These are all mistakes that are bound to happen, and some of you might forget to think about the power of n and they will put 2 or 1 by 2. So that's why your options look like 1 by 8, 8, 2 and 1 by 2. These are common mistakes you will do. Okay, some of you might forget to put the power of n. Some of you might forget that both the k and my 8 are both in the denominator. So my k is 8, not 1 by 8. All of you clear? Yes. See, I have few students making mistakes here. So please, some mistakes. Others are all right. Very few made a mistake. Okay. Now, A is equal to Ka. Determinant of A. This again the property we just now discussed, my dears. Determinant of A is equal to determinant of Ka. And that's going to be determinant of A is equal to K raised to N determinant of A. What is the order here? 2. Order is 2. So can I say determinant of A is equal to K squared determinant of A? So I will get K squared equal to 1. Then what are the possible values of K? That implies K could be plus 1 or K could be minus 1. 2 possible values. Then what is the sum of all the possible values? So what is the sum? Plus 1 and minus 1 added, you will always get 0. Option D. 0 is your answer. So this is just like making you to use the concept. If a student forgot that this is going to become K raised to N, he will get what? Only one value for K. Yes. And what would that value be? And that value would be 1. And that option is there. Option A. And because these are all mistakes that are bound to happen in the exam, my dears. So please be careful when you are thinking about the properties. Okay. Another one. Yes. Very, very important. 2 properties coming again, my dears. 2 properties from the determinants chapter is coming. Okay. First one. The product of any matrix, a square matrix, with its own adjoint. The product of a matrix with its own adjoint will always result in IN. IN means it's an identity matrix. Determinant of A into I. Determinant of A into I. And the second one, what is the determinant of adjoint A? The determinant of adjoint of A is the determinant of A raised to n minus 1. Again, n refers to order. The adjoint of A. Okay, but remember, there are certain cases they ask you double adjoint also, my dears. Adjoint A. Then in that case, it's going to be n minus 1 squared because it is double adjoint. If it's triple adjoint, cubed. Okay, so how many times adjoint comes, that would be the power of n minus 1. These are all properties you must recollect. Now, if you use that logic, here in the question, they said that A into adjoint of A is equal to 300030003. So doesn't this look like 3i? So if this looks like 3i, that implies that my determinant of A is equal to 3. Simple. Don't waste your time calculating and all. The property is enough. You just compare determinant of A into I. So that is 3 into I. So determinant of A is equal to 3. Now they want me to find determinant of A plus determinant of adjoint A, which is determinant of A plus determinant of A raised to n minus 1. It's a 3 by 3 matrix, my dears. So n is equal to 3. It's a 3 by 3 matrix. So n is equal to 3. So substitute, my dears. So what's your answer? 3 minus 1, 2. So it's determinant of A plus determinant of A squared. So there is 3 plus 3 squared. Answer 12. Option A. 12. Yes. Red answer coming, my dears. Yes, Nachipan, Snow, Magasri, Simra, New Rays. Yes. Okay. Once again, remember, when you multiply a matrix with its own adjoint, the answer is going to be determinant of A into I. So if that matrix A into adjoint is given to you, the diagonal will be the determinant of the matrix. Got it? A. Determinant of A. Got it? Now, B is a non-singular matrix and A is a square matrix. Then what is the determinant of B inverse AB? B is non-singular, means the determinant of B is not equal to 0. A is a square matrix. Now what is the determinant of B inverse A into B? Now again, another property coming here, my dears. The property says the determinant of the product of how many ever matrices you want you take. It is simply individual products of the determinants. How many our matrices are multiplied? It doesn't matter. The determinant of the whole product will be simply equal to the product of the individual determinants. So now, what is the determinant of B inverse AB? So can I write it as determinant of B inverse into determinant of A into determinant of B? What's the determinant of B inverse? We just now saw that property before. 1 by determinant B, determinant A, determinant B, and because B is non-singular, determinant of B is not 0, it's a non-zero number, so I can cancel these two. Otherwise it will be not defined. Yes or no? Because it's non-singular, determinant is non-zero, so I can cancel two non-zero numbers. So my final answer is going to be what, my dears? Yes, good answers coming again. Night, Sai, Magashri, Hanna, Simra, Nachipan. Yes, its answer is option C, determinant of A itself. Okay, I hope everybody is getting clear with the concepts and the properties of determinants. These property based question, one question will come in your board exam, 100%, because they have to ask 5 questions from this unit. Where will they go for the questions? One question majorly will come from this, one question from symmetric and skew symmetric, one question from the product of matrices. This is a very, very common pattern they would keep, and nowadays they started asking question, how many matrices are possible? That formula which I said, m raised to n into n, m raised to n into n plus 1 by 2, m raised to n into n minus 1 by 2. These kind of questions are very, 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 very important for us, my dears. Okay, next one. Yes, another one which I saw last year's board paper. So many question sets had a question based on area of a triangle. I could say three regions, the same question came with area of a triangle. So now, what are the formula for finding the area of a triangle? We know the matrices, the vertices are given to us. The vertices are given to us. What would be the area of the triangle, all of you? Half determinant of AB1, CD1, EF1, and we always keep a modulus here because the value of the determinant would sometimes become negative. So to make it stay positive, we always try to consider keeping it inside a modulus. Okay, so half AB1, CD1, EF1, my dears. Okay, now in this logic, if I say, and they say that delta represents the area of the triangle. So I can say 2 delta is equal to determinant of AB1, CD1, okay, CD1, EF1. Now I want the square of this, but you can see that this is transpose. Very clearly, the transpose is asked here. There comes the next property, my dears, of determinants. The property says that the determinant's transpose is same as the determinant of the matrix itself. If you take a transpose of a matrix and you take the determinant, it's still same as the determinant of the matrix itself. So if that powerful property can be applied, this simply can be written as ACE BDF E111. That's what they need. But they need a square of it. If I square it, it's going to be 4 delta square. 4 delta square. Yes, right answer. Very few students said that. Yes, I know it's confusing sometimes, but it's a very, very simple question. Just 2 steps, you get the answer. Okay, so the concept says that property says the determinant of a transpose is same as the determinant of the matrix itself. So I can just simply square it on both sides. I get the answer is 4 delta squared. Next one, again this also came last year. They're asking to find the unknown value k if the area is 35. So according to the concept again, half determinant of 2 minus 6 1 5 4 1 k 4 1 is equal to, we put a modulus, right? But this time I'm not trying to find the area to make it positive. I'm trying to find the unknown value k, so I'm going to remove the modulus and put plus or minus 35 because the area is 35. Now just shift the 2 to the other side and find the determinant. 2 into 4 minus 4 plus 6 into 5 minus k plus 1 into 20 minus 4k is equal to plus or minus 35 times 2, 70. This is 0, so you get 30 minus 6k plus 20 minus 4k equals plus minus 70. So it's 50 minus 10k equals plus minus 70. Now here onwards you have to use two cases, positive, negative. So 50 minus 10k equals 70, 50 minus 10k equals minus 70. From this you get k is equal to negative 2. Here you get k is equal to 12. Negative 2 and positive 12. Option D. 12 and negative 2. Yes, very easy answers. All of you very clear? Yes, again same repeatedly as pattern from determinants. Area of a triangle using determinants method. Okay. Next, A is a square matrix. Again, my dears, see, it's going to collect all the properties we learned till now. Minus 3 is a scalar, A is a matrix, and its transpose A dash. So if I remove the scalar out, it becomes raised to n, and according to the product property, if I multiply two matrices, it's simply individual determinants. Yes, so I use the property of k raised to n, determinant of A, and also the product of two matrices, which is determinant of A into determinant of A transpose. Now it's a 3 by 3 matrix, so it's minus 3 raised to 3. Determinant of A and determinant of A transpose again same as determinant of A. So this is going to be negative 27 times determinant of A is again negative 3, negative 3. So 81 times negative 3, negative 243. Negative 243. Option B. Negative 243. Right answer coming from Madhasri, Ruben, Hanna, Simra. Yes. Again I'm telling you, my dears, property based questions of determinants. One question 100% sure. Okay. Next. AB equal to 6i. Determinant of A is equal to 12. Find the determinant of B. AB. Then what is the determinant of AB? Determinant of 6i. Determinant of AB says it's simply the product determinant A, determinant B. And scalar 6 raised to n. Some students, again we forget this. Yes, it's determinant of I. So what is determinant of A? 12. And what's determinant of B? That we have to find out. And 6 raised to n is 6 raised to 3 determinant of I, or determinant of I. It's an identity matrix which has always a determinant called 1. Yes, so determinant of B is equal to 6 cube 216 divided by 12. It's 18, my dears. What's the answer? It's 18. Yes, option C, 18 is your answer. 216 divided by 12. Okay, now yes, easy. The question looks very vast, but just simple statements, read and tick and go. A is a 3 by 3 square matrix. Which of the following is not correct? This is the dangerous thing. Many students read the question so fast that they do not see this word, and most of the cases they'll say is correct, and option A would be a correct answer, and you will tick and go. Again gone. So please read the question. Statement based questions, which of the following is not correct, is very dangerous. Okay, order of a minor is less than the order of a determinant. Correct? It is correct. How is a minor obtained? Minor is obtained by minor of an element, say 2, 3, 5, 1, 4, 2, minus 1, 0, 1. If you want to get the minor of this element, you eliminate this and this, what is the remaining? That's called the minor. So the minor will have an order less than the order of the determinant, so it is correct. So I want something which is not correct, so neglect it. Minor of an element can never be equal to cofactor of the same element. Check. How do you calculate cofactor? Cofactor is calculated by if this is the minor Mij, cofactor is calculated by minus 1 raised to I plus j multiplied with Mij. You multiply the minor with a numerical value. So if this numerical value turns out, it's all powers of 1. If this numerical value turns out to be 1, cofactor will be equal to minor. But if the numerical value sometimes turns out to be minus 1, cofactor is not equal to minor. So they said it can never be equal to the cofactor, but sometimes it is equal. So that is also wrong. Option C, value of a determinant is obtained by multiplying elements of a row or column to the corresponding cofactors. That is the definition of determinants. That is the definition of determinant. Determinant definition says that it is obtained by selecting any row or column and its elements are multiplied with its corresponding cofactors and then added. Okay, so this is also a correct statement. Okay. Oh, one minute. I wanted which is not correct, right? So all of you just listen. I want which is not correct. No. So minor of an element can never be equal to the cofactor. Is it correct? It is not correct. So this is your right answer. Okay, this is wrong. Order of a minor and cofactor of elements is the same. Minor and cofactor have the same. So it's a correct answer. That is, we don't want that also. The only one which is not correct is option B. The only one which is not correct is option B. Minor of an element can never be equal to, it is sometimes equal. Okay, so with this we come to the conclusion of our session on matrices and determinants. I have discussed around 30 MCQs today from this unit because it's very, very important for us. Okay, so please, my dear students, follow this video. Come back again and watch this video again in the YouTube channel if you want to clear some more concepts and properties based on matrices and determinants. Okay, so see you again tomorrow. I'm coming back live again tomorrow with vector algebra. So please stay tuned and we are going to start the chemistry session after this within 15 minutes. Thank you, my dear students. Signing out. See you tomorrow.